Welcome to Module 5, Lesson 2. So today we're actually going to talk about least squares regression lines and correlation. So I have a video of me actually exploring this wonderful problem right here in an applet. Please watch that video so that you can see how the applet can really help you with problems like this, because it will graph it for you. It will do all kinds of wonderful things for you. It'll tell you your correlation and such. So make sure you watch this video right here of me exploring that problem. Okay, so moving into today and what we are talking about in this lesson, these right here are the notes for correlation coefficient, and that's going to be an important part of least squares regression. So yesterday we already went through and looked at scatter plots. So quick reminder on that, this unit we are looking at two quantitative variables measured on the same observation or person. Okay, so two different things measured on the same observation. Okay, so when we were talking about linear relationships, which is going to be the thing that we focus mostly in this class on, when we have a linear relationship between those values, we can make what's called a least squares regression line. We're going to dive into that tomorrow, and we're going to actually be starting to create those least squares regression lines in our applet or in your TI-84 app that you can have on your Chromebook. But for now, we're going to talk about the R value associated with that in the correlation. So when we have a scatter plot, and I'm going to definitely be referring to one or two in a minute, we can tell whether there is a strong linear relationship or a weak linear relationship. If there's a strong linear relationship, then it means that your data is going to be very close to a straight line. If there's a weak linear relationship, it means that the points are all scattered about and it doesn't look like there's any kind of linear relationship. We're not going to be able to use that least squares regression line if it has a weak correlation. And when I say correlation, that really amounts to that strength when we talk about correlation. Okay, so correlation is going to be the value R for us. I think of like correlation, that's our R value, our R value. And what it measures, there is a formula here that I'm going to actually avoid, but I'm going to talk about what it shows. We're going to just get this from our applet, so I'm not going to take the time to really go through and dive into a problem, but I will talk about what it means. R measures the direction and strength of a linear relationship. I'm going to say that again because that's the most important thing today. It measures the direction and the strength of a linear relationship. Direction meaning a positive association or a negative association. The strength is going to tell us, we have R values and I'll tell you what those ranges are, but it's going to be able to tell us how strong a linear relationship is. If it has a strong linear relationship, we're going to have R values that are close to 1 or -1. If it has a weak linear relationship, we're going to have R values that are close to 0. And again, I'll show that to you in a minute. It says here so like when we're actually calculating it, what are we looking at? In this case, you're really taking the variation in your x's and dividing by your standard deviation, and the variation or the distance of your y's from your mean and dividing by your standard deviation. You're multiplying those together, you're adding them all up, you're dividing by that. Really what you're looking at is the average product of the standardized values. You're kind of looking at the average product of the standardized values, meaning like how far are these, okay, how far are these from what's going to be this least squares regression line that we have. Okay, so facts about R, the important parts of R. R can take on positive or negative values. If your R is positive, it means that your slope of a line would be positive as well, and it means that there's a positive association between those two different variables that you're looking at. If it's negative, then it means your association is negative. Values that are really close to 0, like if you have a positive 0.2, that's pretty close to 0, or a negative 0.2, that's close to 0. Those are going to be very weak correlations. The closer your values are to 1 or -1, they indicate a strong relationship. So if I had an R value of 0.9, it means most of those points are like on a nearly straight line. Okay, so that's very strong. A 0.9 is a strong association. A 0.8 is a moderately strong association. I'd even say a 0.7 is moderately strong. Anything less than 0.7 is going to be a weak association. Okay, but the same thing goes of the negatives. So every value closer to -1, again, the negative only tells you the direction. So if I had a negative 0.9, it's just as strong as the positive 0.9 that I just had. It's just that the slope is negative. I'm going to show you an example of this in a minute. A couple of things that you need to know about correlation. Correlation makes no distinction between explanatory and response variables. So even though I told you yesterday, you have to have your explanatory, you have to have your response on the right axis, your R actually wouldn't be affected at all. You're going to get the same exact R if you flipped them and you did those wrong. What will be wrong is your entire least squares regression line. So it would be a big mistake to switch those. But for your R value, it actually doesn't make a difference. The other thing is correlation only measures the strength of a linear relationship. It doesn't work for curved data. It's not resistant. If we change one of the values, it will drastically change your correlation. And the other thing you need to know about it is that if you were to change, they have no units at all. You can't say that like R is 7 inches. That doesn't make any sense. Because imagine if you're measuring inches in GPA, inches in height and GPA of students, which would be a silly thing to measure. But if I was measuring those two things, your R value is looking at both of them. So would it be inches and GPA? That doesn't make any sense. R does not take on that. It only tells you how strong or weak a correlation is. Okay, so those were the notes. I want to show you a couple scatter plots, and I'm going to do that by actually going to your assignment. Your assignment for today lists these right here. So I'm going to kind of talk about them by looking at the graphs of these. In A, this definitely is a strong positive relationship. Like if I were to draw a line to try to capture this data right here, this is a strong positive trend. Remember how we said, so my positive R values are down here. Remember how we said the closer they are to 1, the better they are, or the stronger they are. And then as they go down and get closer to 0, that means that they're weak. This one right here is pretty strong and it has an R value of 0.9. I will say that you can have an R value of 1, and that would mean that every single point is exactly in line with each other. So you can have an R value of 1. You can also have an R value of -1. It would just mean every single point is exactly in line, but the slope is negative. This one would be R equals 0.9. This one, however, is completely scattered. This is completely scattered. This right here, I can't even tell where a line would go at all. This has an R of 0. That's going to be a correlation of 0. There's no positive or negative trend in that data. In this one, there's another positive trend, but it's very weak. This is a very weak trend. It's very spread out. This would have an R value of 0.3 because that's very weak. This one is the same type of thing. It's very weak, but it's in the negative direction. I could attest that this one, if I really looked at it, it looks like it's a negative trend. So I would actually make that an R value of -0.3, which is, again, close to 0. Those are the same distance away. It's just that this is a negative one. So this one looks to be -0.3. This one is going to be a strong correlation as well. So this one will be a strong correlation, probably not as strong as this one. I would say that this one is probably going to be a negative 0.7. This would probably be a -0.7, but I actually would accept either one of these, 0.7 or 0.9, just recognizing that it's a negative association and a little bit higher. And that's all I'm going to talk about today with correlation. So pop in and do the homework. I do have the homework answer key below.